Academy. Our today's topic is even divisible elements in a linked list. This is a very interesting problem, so let's get started. Before starting it, I'm just going to be assuming that you people are already well versed with what a linked list is and how do you perform the insertion and deletion operations here. Okay, so in this particular one, they are saying that given the number of nodes in a linked list, you have to just we have to just take all the elements from that linked list and you have to print even numbers present in the whole list which are divisible by 3. And if there are no even numbers in the whole list, you have to print empty. So you have to take care of the two condition checks. So first one is even elements divisible by 3, and the second one is if we do not have any such elements, you just have to print empty. So first of all, what I will be doing, I'm just going to be quickly creating a program which is going to be taking the elements, inserting the elements in our linked list, and then we are going to be printing one code where we are going to be just printing out all the methods. Once I'm going to be get done with that particular part, then I'm going to be coming back here and then we are going to be integrating all these conditions there. So let's quickly move to our Visual Studio Code. Since this is an extremely easy problem, I'm not even using the writing pad here because all these things are extremely easy. Trust me, this is the easiest problem. So we are here. So what is the first thing which we will have to do? So for the linked list, I'm going to be creating a class, and that class I'm going to be naming as linked list. And this particular one, I'm going to be defining a constructor. With the help of that constructor, I'm going to be assigning the elements of my linked list. All right. So I'm going to be creating a constructor, and here I'm going to be taking an element. Then I'm going to be setting to my this dot element to the element value which I'm getting as a part of this constructor. And whenever we are going to be considering the linked list, and all things we have the current element plus the reference to the next one, right? So at the time of creation, I'm going to be setting the next value as null. So later on, when I'm going to be inserting the nodes, that time I'm going to be establishing a relationship between them. So after that, what is the next thing which we will have to do? Or let's name it as node. I'm going to be naming the another one as linked list, where I'm going to be using this constructor plus where I'm going to be actually performing all my other operations. So let me create a class linked list here. Okay, in that particular one, I'm going to be creating a constructor. And in this particular constructor, what I'm going to do, so the head, I'm going to be initializing it to null. Because by default, everything has to be null, right? And this dot size. So that also I'm going to be initializing it to 0 because by default, everything has to remain 0 only, right? After that, what we are going to do, we are just going to be creating a method which is going to be adding all the values to your linked list. So let me call that method as insert. In this particular one, I'm going to be taking an element, and that element I'm going to be inserting in my linked list, and this particular one is going to be adding the elements to the list. So let me add that comment here, adds element at the end. You can actually go ahead and pick any one. The reason why I opted this one is when we are going to be added it at the end, I can actually see my list growing. It's up to you, whatever you want to use, because this problem is actually related to the conditions which they have given us, right? So after that, what I am going to be doing, I'm just going to be creating a node, and for this node, I'm going to be using the node class constructor. So here they are going to be expecting an element, so that one I'm going to be passing here. After that, what I'm going to do, I'm just going to be storing the current node. So how I will be doing that, I'm going to be creating one instance that is going to be current, and later on what I will do, I'm just going to be performing a condition check that if the list is empty, then it is going to be the head of the element, right? So for that particular one, I'm just going to be doing a condition check which is going to be this dot head is equals to null. In such a case, what you will be doing, you are going to be initializing to this dot head to the given node which you are having. Otherwise, what you are going to do, you are going to be updating the current one. So in your current, you are going to be passing the this dot head. After that, what we will be doing, we are going to be iterating in our whole list. Why I'm going to be doing it in that form? Because I'm going to be adding the element at the end. So for that, let me take while here. So as long as your current is going to be having a next, we are going to be moving ahead. Okay. And here what I will be doing, I'm going to be using my current, and I'm just going to be using current.next. So how that is going to be helpful, because this one is just going to be incrementing to the one step ahead. As long as you are going to be having the elements, this particular one is going to work. Otherwise it is going to reach to the end, and after reaching at the end, we just have to go ahead and add our node, right? So after coming out of it, what we are going to do, your current.next is going to be pointing to your node. So this is how this particular code is going to be working. After that, what we will be doing, I'm just going to be updating my size. So this dot size, or this size is actually not required here. The size is required only when you are going to be inserting the elements at the random position. Since we are not going to be doing that, let me just skip that particular part. Okay. So after that, what I'm going to do, I'm going to be creating one method like this insert. I'm going to be creating one method which is going to be printing the elements of the linked list. And later on, I'm going to be making the certain changes here only. Okay. This one I'm going to be naming as print list. Now inside this method, I'm just going to be checking that what and all elements are going to be there. So firstly, I'm going to be taking my current pointer. This one is going to be pointing to the head. Later on, I'm going to be taking one string. That string is actually going to be used only for the printing purpose. So, or you can name it as output only. Okay. So this output, later on what you can do, while your current is going to be there. So same iteration, whatever we have used at the time of inserting the node, same iteration we have to use here. So here what we will be doing, we are going to be doing like whatever your output is there, to that particular one, I'm just going to be adding my current element dot element and then some space, so that every value can actually come in one place. And after that, I'm going to be moving my current to the next value. Sorry. So current dot next is actually going to be doing that part for us. And at the end, after coming out of this for loop, while loop, I'm just going to be consoling out. So console dot log, and here we are going to be putting the output. So let me quickly run and show you the output for the same. Oh, okay. So we have not even initialized it. Sorry. So what I am going to do, I'm just going to be creating a linked list, and here I'm going to be initializing my linked list class. And after that, I'm just going to be adding certain of the values here. So how I can do, ll dot insert. So let me add 1. Then I'm actually copy pasting it. So then let me add 2, 3, 4, 5. So I have actually added 5 values to my linked list. After that, I'm just going to be calling my print method here. So that is going to be ll dot print list. Let's run and see the output for the same.